Hey guys, it is Campbell. Today we are going to be working on question 3 for the 2024 AP Calculus BC exam, so let's go ahead and jump right into it. Question 3 says, the depth of seawater at a location can be modeled by the function h that satisfies the differential equation dh dt equals 1/2 of h minus 1 times the cosine of t over 2, where h of t is measured in feet and t is measured in hours after noon, t equals 0. It is known that h of 0 equals 4. For part A, we are asked to sketch the curve that is the solution to y equals h of t through the point 0, 4. Gonna be honest, these questions might as well be a free point. You can simply make your curve go through the given point and follow the shape of the curve that you're given. You can estimate your curve better by quickly calculating the slope at a given value of t in your head based on the differential equation you're given in the question. But really it's pretty simple. All you do is just start at this point and then roughly follow the shape of the curve, and that is that question done. Part B says, for 0 less than t less than 5, it can be shown that h of t is greater than 1. Find the value of t for 0 to 5, not inclusive, at which h has a critical point. Determine whether the critical point corresponds to a relative minimum, a relative maximum, or neither a relative minimum nor a relative maximum of the depth of seawater at the location. Justify your answer. Remember that a critical point is where the derivative of the function is either 0 or undefined. So to find this point, we simply take the differential equation from the question and set it equal to 0. Since on the interval we're given, h of t is greater than 1, we know that the first part of this function, the 1/2 times h minus 1, because it tells us on this interval h of t is greater than 1, we know that this is always going to be greater than 0. If that makes sense. So really what we need to find is where cosine of t over 2 equals 0. So because we all remember our trig values, we know that this value of t lies at pi. And that is the only value where cosine of t over 2 is equal to 0 on the interval 0 to 5. Now, to determine if this point is a minimum or a maximum, we need to make our line and plug in values both above and below pi to determine which side is positive and which side is negative, or if it swaps at all. So let's go ahead and make our line here. Make sure that it is h prime or dh dt. And right here at pi, we know that it is 0. Now remember that between pi and 3 pi over 2, cosine is a negative value. Because our maximum in this interval is 5, if we plug in 5 for t, technically the maximum value we can get from this cosine function is cosine of 2.5. Now 3 pi over 2 is a little over 4. It's 4 and some change. And that is obviously going to be bigger than 2.5. So we know that in this interval after pi, cosine is going to be negative. And we know that before pi, cosine is positive between 0 and pi over 2. And remember, when we plug in pi, we're actually getting cosine of pi over 2. So this means that we go from positive to negative. We know that this is going to be a relative maximum. So we're going to justify and say that h has a critical point at t equals pi hours after noon, since h prime of pi is 0 and at h of pi dh dt goes from positive to negative. And that should be all of the justification that we need. Oh, excuse me, no. We also need to determine whether it's a relative maximum. So we say that h of pi is a relative max. And that is all the justification we need for that question. Now, I know that some of you may be tempted to use the second derivative test to determine whether this is a maximum or a min, but please, do not try to derive the differential equation it gives you. That would be stupid, okay? Just plug in the points that it gives you, use your common sense, use your thinking cap, and determine whether it's a max or a min. Don't try and second derive this stuff it gives you. That would just be silly. On to part C, we are told to use separation of variables to find y equals h of t, the particular solution to the differential equation dh dt equals 1/2 of h minus 1 times the cosine of t over 2, with the initial condition h of 0 equals 4. This is going to be a fairly simple question. Like it says, we separate our variables and simply integrate both sides. So, always start out just with the original equation it gives you. And then we are going to separate. And we can integrate both sides now. And over here, we should recognize this as the natural log of the absolute value. And over here, this is simply going to be sine of t over 2. If we let u equal t over 2, our du is obviously going to be 1/2 dt. So that solves pretty well. Remember to add our constant of integration. And we're given the initial condition h of 0 equals 4. Now this means that t is going to be 0 and h is going to be 4. So this is natural log of 3 once we plug in our 4 minus 1, and that is going to equal sine of 0, which is just 0, plus c, which means c is the natural log of 3. So now we can further solve this. Now, I believe you should be able to leave it in this format. If you would like to further solve it, then you can make it h minus 1 equals e to the sine of t over 2 plus the natural log of 3, or h equals e to the sine of t over 2, plus the natural log of 3 plus 1. And because you have addition up in your exponent, this is going to be the same as, let me fix this here. This is also going to be h equals 3 times e to the sine of t over 2 plus 1. Since, of course, we all know e to the sine t over 2 plus natural log 3 is the same as e to the sine t over 2, times e to the natural log 3, and this is of course just 3. So our final most simplified answer is going to be 3 e to the sine t over 2 plus 1, but I believe you could also leave it in this form. And that is the end of part C and the end of question 3. Hopefully that you can see that while these questions can be worded strangely, while they may seem difficult, it is a very straightforward process to solve them. And the most difficult part for you, it probably won't be the calculus, but the justifications. Make sure you word your justifications correctly and succinctly, and you shouldn't have a problem. But as you saw earlier, I almost forgot to justify that, or answer one of the questions that whether it is a relative maximum or a minimum. So just make sure that you remember everything in the question, read it a couple times if you have to. I will be continuing this series later, and again, I will also be doing the questions from the AB exam if you're interested. Please leave a like and consider subscribing if you found this useful or if you just enjoyed the video, and I will see you guys next time. Bye!